Welcome to our introductory Python course, Python for Beginners. I'm Omega Silva. This is part 2 of our 3-part lesson on writing clean code. In this session, we are planning to focus on readability of code. We are going to look at an example, look at some code, and try to understand techniques in writing clean code. Before we proceed, let's have an understanding of the color coding that we have used across this presentation. If you see red color text, that means they're extremely important. Blue is also important, so you have to pay attention to them as well. We have used green to indicate terms and terminology, whereas purple indicates slightly off topic, but content that is required to make a point. Now that you understand the color coding, let's dive into this session's content. Let's try to recall what we learned in part 1. We discussed how a code base changes over time. We also discussed how a software development team changes over time. Through this, we came to understand that if your code is not clean, it is very difficult to read and understand, and therefore change your code. We also looked at the definition Grady Booch provided on clean code, and we identified the 4 main characteristics of clean code. These are the 4 main qualities of a clean code base. As developers, we should always get our mindset aligned with these qualities so that you could adhere to them while you're writing code. Delaying to clean up code is not a good idea, simply because other priorities may continue to keep the code cleanup tasks further delayed, and it will lead to an unhealthy code base. Out of these 4, we are going to focus more on readability. These 5 techniques are selected out of many because these are the basics of writing clean code. They're simple to understand, yet if you keep on applying them when you're writing code, your code readability will improve significantly. In today's session, we plan to discuss about the first 2 techniques. To discuss these techniques in more details, let's look at an example. We have selected a scenario of lending a book to a member from an online library management system. The diagram that you see here, which explains the scenario, is known as a flow diagram or a flow chart. These diagrams are used to discuss a decision-making process and the actions that happen after the decisions are being made. The black color circles, they represent the start and the end. The square shapes, they represent the actual items, which can be done either by a human or could be done by just code. The diamond shapes, they represent the decisions that are made along the way. Now, I recommend that you pause the video and read the text on each of these shapes so that you could follow my explanation of the scenario in a more efficient manner. The scenario starts with a user of this online library management system requesting to lend a book. Once the request is being made, the system checks whether the user is an actual member, and if so, whether the member has already lent 2 books, and if not, whether the requested book is available. Then it calculates the requested book's new return date and then assigns the book to the member, assigns the new return date, which we call as the checkout process. If any of these validations fail, the system would send a message to the user why the book lending process could not be proceeded forward. And after that, it ends the process. Let's look at a Python function which implements the logic which was described in the flow diagram that we looked at earlier. Again, before we proceed with the explanation, please pause the video. And if you don't recall the flow diagram, go back and look at the flow diagram again and read the code that you see on the screen so that we can follow the explanation in a more efficient manner. Also note, when I am explaining the code, I am not reading out the underscores on function names, the variables out loud. The method name here is lendBook, and it obviously takes two parameters, MID and BID. We don't know what they mean, but let's follow along. The first line that we see in the method is a validation, an if condition, which calls a function check DB member, and it passes the MID. Now, trying to recall the flow diagram that we looked at earlier and trying to relate this to the code, I can guess this function may be validating the member ID to see whether the member is actually a member. And if it is valid, it checks whether the member has lent two books for the time being. And it seems the getBook method, which takes the member ID, returns the books that the member has already lent. Thereafter, it checks whether the book is in the database. So the name suggests check DB book. But again, relating this to the flow diagram, this seems to be the function which checks the book's availability. After that, if all three validations are successful, it captures or rather calculates the return date. Now this is very clear because the variable name used, it is actually the return date. So it gives me an indication the logic highlighted is about calculating the return date. And there is a function that's called update DB book checkout. But the word checkout indicates this is the last step of the book lending process where the checking out of the book actually happens. The else structures, they are self-explanatory because of the messages that it prints. They are essentially providing a valid reason for the user for not proceeding with the book lending process. When we looked at the flow diagram, the logical flow, the decisions that it makes, the actions after the decision making, they were quite clear. But the Python function, which implements the same logic, seems a little bit difficult to understand. Categorically speaking, this difficulty of reading code is due to two main factors. The first one, which is very important, is not using proper contextual names for both variables as well as for functions. The second thing is this function does too many things. Let's look at a few examples. Starting off, the two arguments that are passed, it does not have self-descriptive meanings. We have to guess along the way what MID and BID means. The same continues for function names. Check DB member. Even though this is a valid function name, it does not tell what the function does and what it evaluates. This is a little bit descriptive because books and the greater than two is easier to understand because we already had a look at the flowchart. The same argument goes here, not a good name for this function. Now this calculation here, it is a little bit descriptive simply because the variable that's used, its name is return date. And we can easily relate this calculation to the step in the flow diagram where it calculates the return date. And these else conditions, they are self-descriptive because it is a message in plain English that gets printed.